Hello and welcome to Fraction Multiplication Part 1. If you're watching this video, you perhaps have been to my website, mathlearningjourney.weebly.com. And if you've been there, maybe you've read some of the material I've left about mathematical knowledge for teachers. Um, if you have, you've seen this graphic before, and it talks about the different domains of knowledge that teachers require in order to teach mathematics effectively. I'm not going to say too much about that right now because the information is on the site. So today we're going to talk about multiplying fractions. And the procedure for multiplying fractions is very easy to do, but the concepts that underlie the procedure are somewhat challenging. And as teachers, we need to make sure that the students actually understand these concepts and are not simply going through motions that they don't understand. So let's take a look at a few misconceptions about fraction or problems with fraction multiplication. The experts tell us that students tend to lose the meaning of operations when fractions are involved. So a student who understands whole number multiplication well will often have difficulty retaining the meaning of the operation once fractions are in the mix. This is a misconception. Students have been conditioned, they may have been conditioned because of their experience with whole numbers, to expect that the product is bigger than the factors in a multiplication question. And when this doesn't happen when they're multiplying fractions, they become confused and have a hard time accepting it. So one of the things we must do as teachers is to allow students to see what is actually happening in the operation so they can see that a smaller product makes sense. A couple of things to keep in mind when we are teaching fraction multiplication. One right here. We want to capitalize on the understanding that students have of whole number multiplication. So we're going to start there with whole number multiplication, talk about what that means and what it looks like, and then gradually introduce fractions, trying to keep that meaning, that operational meaning, intact for the students. The other thing that we're going to do is we're not going to introduce the algorithm. We're going to present multiplication contexts, fraction multiplication contexts, with clear representations, visuals that they can look at. And we're going to put the students in a situation where they can see what is happening, take a look at the numbers involved, and come up with a procedure that will work and will match the images that they're seeing. So that's where we're going to go as we investigate fraction multiplication. So let's take a look at some multiplication, and let's begin by using a number line presentation. So I'm going to open my number line app, and there it is. So as I said, we're going to begin with whole number multiplication, and let's keep it really simple. So if I write down 2 times 3, we all know the answer. It's going to be 6. But what does this look like? And this is what we're going to talk about with the students. I start at 0, and I'm taking 2 jumps of 3, or 2 groups of 3. So there's a group of 3, and there's another group of 3, and my answer is where I land. That's 6. Fantastic. Okay, so what if I change the question, and I'm going to change the color too, so let's go with orange this time, and I'm going to keep my 2, but this time I'm going to multiply by 2. And we all know that the answer is 4, but let's prove it. So again, I start at 0, and I'm taking 2 jumps of 2, 2 groups of 2, right? So there's 1, and there's another 1. Perfect. Now let's continue in this fashion. Let's go with yellow, and this time we'll go 2 times, you guessed it, 1. And we know 2 times 1 is 2. But this is 2 jumps of 1, 2 groups of 1. There's a group of 1, and there's another group of 1. Now this is a good time to stop and have a conversation with the students and say, okay, well look what's happening. What is changing? Well, the second factor is decreasing each time we change the question, and that is causing the product to become smaller as well. So maybe it's a time to say, well, what if we continue to decrease that second factor? So we have 2 times 1/2. What is that going to do? And get some predictions. And if they're able to see the pattern that's evolving, um, they'll come up with the answer that is going to be 1, because it's going to be 2 jumps of a half, which I have a hard time showing on this number line. But there they are. That's 1/2 and another half, and I land on the 1. This is a good time to talk about that misconception about how in whole number multiplication, uh, a lot of the time the product is larger than either the factors, although that doesn't actually happen here, does it? And that's a good thing to point out to them, that this misconception that they have doesn't actually exist 100% of the time in whole number operations. In this case, 2 times 1 equals 2. The product is equal to one of the factors. So that should open the door to a consideration that perhaps the product can be smaller than the factors, which is what we have over here. Okay? Now I'm going to change my number line and to add fractions to it, but when I do that, all of this is going to disappear. I can't stop that. So I'm going to ask for fractions, and let's say I'm going to go to 1/3, and that's going to erase everything. Unfortunately, I can't do anything about that. So let's just review what we had. We had 2 times 3 equals 6. 2 times 2 equals 4. 2 times 1 equals 2, and then we did 2 times 1/2, and that was 1. So now we can ask the students, well, what about 2 times 1/3? What's that going to look like? And we can actually model that right here because we have the thirds. So if I start at 0, I go once, twice. There are my 2 groups of thirds, 2/3. And again, stop and address that misconception and ask the students if they see how the product is smaller than one of the factors used. And this is a good opportunity to get students used to that idea. One thing that is really important for students to be aware of whenever they're dealing with fractions, either with operations or without, is what constitutes the whole. They need to know what the whole is in order to really make sense of the fractions that they're using. And I like the number line because the wholes are right there. We can see on the number line that the number 1 is here, so we can see how big one whole is, so that when they're comparing their fractions to the whole, it's easy to see. With the 2 questions and answers that we have written here, students can actually begin thinking about a procedure. And it may be early yet for them to really get a sense of how they might do this without a representation, but they could start thinking about what they see and what is common between those 2 questions. Some might come up with the idea that they're multiplying the first whole number factor by the numerator of the second factor to get the product. And others may not, but it's something that could be given to them as a prompt to at least begin thinking about. I'm going to switch apps. I'm going to go over to my rods app and see if we can represent what we've just done in a different way. Students benefit from varied representations of all mathematics, but particularly multiplying fractions. And so while the number line is good, I also like to use rods as well and area models. So let's take a look at those same questions again. The first question that we had was 2 times 3 equals 6. And I've selected here the green rod as my whole. So we're going to just remember that. And I'm going to grab a gray one out here and I'm going to stretch it out to make a group of 3. And then I'm going to grab another one. And that's going to be another group of 3 eventually. And so those two groups of 3 make 6. 3 plus 3 is 6. If I could lay them out end to end, I would, but space is limited. So that could be my visual of 2 groups of 3, 2 times 3. Similarly, if I'm just like we did in the previous app, the Numberline app, we went from 2 times 3 equals 6, and then we considered 2 times 2 equals 4. I can model that here. I've got 2 groups of 2, and that makes 4. And this should be fairly simple for students to pick up on. Now, just like we did in the previous app, we changed our question again, bringing that second factor lower. 2 times 1 equals 2, which we can see, and this time I can put them end to end, and I can put my 1 here and my other 1 there, and it's easy to see that the 2 1s equal to 2. And again, this should not be new to the students. Now, when we're bringing in fractions, so we're gently leading them from whole number multiplication into fraction multiplication, keeping it really simple because we're keeping one of our factors as a whole number right in their comfort zone. So taking another look at 2 times 1/2. Well, I have some halves here. So if I have 2 1/2 pieces, what does that equal? Well, there it is. It equals 1. So we have our answer. And I can go even further because I have more rods at my disposal. So let's consider 2 times 1/3, which we did on the previous page. And let's grab a third and a third. And let's actually move those down, and we can see that a third and a third are less than a whole. And of course the answer is 2/3. I have 2/3 together. Now if I wanted to, I can go even further and start multiplying sixths, right? So I can write 2 times 1/6, and if students drag down 2/6 and put them together, they see that those 2/6 actually equal 1/3. And again, this might be a good opportunity to prompt students to wonder about the procedure, what is happening there numerically to have 2 times 1/6 equaling 1/3, and see if they can develop some ideas as to a numerical procedure instead of being given it by the teacher. Again, if they develop it, it's based on something that they've learned and now understand. That's going to be it for part 1 of this video. Please see part 2 as we go further into fraction multiplication.